So we've been doing some exact values already. For example, sine of pi on 2. So the ones that we've been doing are multiples of pi on 2 or 90 degrees. And the strategy we've been using is find out where we are in the unit circle. So here is where we start and move pi on 2 or 90 degrees. Consider the coordinates there, which is x is 0, y is 1. And we know that sine is the y value. So sine of pi on 2 is equal to 1. We use a really similar strategy for other ones in the first quadrant, or second quadrant, third quadrant, fourth quadrant. So let's have a bit of an explore of the unit circle and see some of the symmetrical properties. We've already done this, so this should be a little bit of a review, so hopefully it's okay. All right, so on the unit circle below, mark an angle of 30 degrees and 150. Sure. There's 30, and here is 150. What do you notice about the y value of the unit circle in both instances? Okay, so let's check out this. So if we were checking out the coordinates there, so here's an ordered pair of x and y, and here's an ordered pair of x and y. Let's have a look across at the y value at that coordinate. It's there. Let's have a look from here. It's there. And what do you notice? They're exactly the same. Okay, and it looks to be 1, 2, 3, 4, 5. It looks to be a half. So the y value is the same there and the same there. So it is the same. So our conclusion, that shouldn't be a subtract sign. Our conclusion, the sine of 30 is exactly the same as the sine of 150. All right, let's just try that very quickly on the calculator to confirm that. So the sine of 30 is a half, and the sine of 150 should be a half. The y value here should be exactly the same, and it certainly is. All right, so the basic process that we did there replicates the method we used to find many exact values. So where am I on the unit circle? That's the first step. What axis contains my value, i.e. x axis or y axis? Am I negative or positive? And we write that sign down. And what's the equivalent first quadrant angle? So sine of 150 is equivalent to the sine of 30. And we write that down, and then we evaluate it. Now, how do we remember our exact values? Okay, so what we do is we think about two triangles. I call this the isosceles 45. Okay, so here it goes. Okay, I should rule this up. So this is the first one that you would draw. This is the isosceles 45, 45, and 90-degree triangle. All right, now remember 45 degrees is in radians pi on 4. Think about it. All the way across to there is pi, okay, and that's 180 degrees. We want to split it 4 ways, okay, so pi divided by 4 means it's 45 degrees, okay, so that's the 45 or pi on 4. All right, so we can say that that's pi on 4 and that's pi on 4. Now, because this is an isosceles, what we're going to do is we're going to let that side be equal to 1 and let that side be equal to 1. So that's 1, 1. And this one, according to Pythagoras' theorem, will be c squared equals a squared plus b squared. C squared equals 1 squared plus 1 squared. C squared equals 2. C equals root 2. In this case, we'll take the positive. So that's root 2. All right, and this triangle here will allow us to get the cosine, sine, and tan when the angle is 45 degrees. So we could do it from here and go the opposite over the hypotenuse. The sine of 45 is 1 on root 2. The cosine of 45 is the adjacent over the hypotenuse. That's 1 on root 2. And the tan of 45 is 1 over 1 is 1. Okay, so let's just write those down. So tan of pi on 4 or 45 degrees is 1. Sine of pi on 4 is equal to 1 on root 2, and cosine of pi on 4 is equal to also 1 on root 2. It's the same. Right, the other one that we want to think about is an equilateral 2, 2, 2. So I'm going to draw an equilateral triangle. 2, 2, 2 is our side lengths. All right, now what we do is we split that, noting that for an equilateral, that's 60, that's 90, and that will be 30. Right, let's write our radians equivalent to 60. So 60 is 180 degrees split into 3 parts, or pi split into 3 parts. That's pi on 3. And 30 degrees is pi on 6. It's 180 degrees split into 6 parts, so pi on 6. All right, so I know that that's 2. This length here will be 1, and according to Pythagoras' theorem, that is going to be, let's do it, c squared equals a squared plus b squared. That is 4, so 2 squared is 4 equals 1 squared plus b squared. B squared equals 3, b equals the square root of 3. So that is the square root of 3. And now what we can do is we can use these values here to work out the sine of pi on 6, the cosine of pi on 6, and the tan of pi on 6, and also the sine of pi on 3, the cosine of pi on 3, and the tan of pi on 3. So what are they? Okay, so pi on 6. So here's pi on 6, and we're doing sine, which is the opposite over the hypotenuse. So that is a half. Cosine is adjacent over hypotenuse. That's going to be root 3 on 2. Tan is going to be opposite over adjacent, which is 1 on root 3. All right, on to pi on 3, which is over here. So let's do sine, which is opposite over hypotenuse, which is root 3 on 2. Cosine is adjacent over hypotenuse. That's a half. And tan is going to be root 3 on 1, which is root 3. So there's our exact value. So we should be able to get, using these triangles here, an exact value for 45 degrees, 60 degrees, 30 degrees, on top of the multiples of 90 that we did in the last lesson. Just looking through some old PowerPoints to construct this lesson, and saw this one on one of Mr. Tench's PowerPoints. Before you do any question, you must draw the special triangles, that's those two, and a unit circle. Don't bother otherwise. All right, so let's see what he means. Here is the cosine of 5 pi on 4. Okay, so here is my unit circle. So the first thing we need to do is, where are we on the unit circle? So the way I like to do this is I consider what 4 pi on 4 is. So 4 pi on 4, 4 pi on 4 plus pi on 4 is the same thing. And 4 pi on 4 is pi plus pi on 4. So pi is here, and we're going pi on 4 more. So pi on 4 is another 45 degrees past 180. So this is where we are on the unit circle. Okay, so we've located our position. Okay, the next thing we do is we work out whether we are going to be negative or positive. Now, I'm following my steps that I wrote down here. So where am I on the unit circle? What axis contains my value? Is it x-axis or y-axis? And am I negative or positive? All right, so what am I doing? I'm doing cosine, and cosine is the x-axis. All right, so what I do basically from this point here is I look up and I work out that I'm going to hit the x-axis on a negative number, or at a negative value. So the answer is negative. We write down our trig ratio, which is cosine. And then what I do is I don't know what the cosine of 5 pi on 4 is. I'll only know ones that are in the first quadrant. Okay, so the tactic is going to be that I'm actually going to go to the first quadrant and mark 45 or pi on 4 there. That will give me this value here, this x value here. The cosine of 45 will give me this, which I then drop a negative sign out the front, which will give me that value there. Okay, so I'm going to get the cosine of pi on 4. Right, so what is the cosine of pi on 4? This is the triangle I use, pi on 4, and we're going to use cosine, or 45 here. I can do whichever one I want. Cosine is adjacent over hypotenuse, so it's 1 on root 2, so negative 1 on root 2. Let's try that on our calculators. So let's get the cosine of shift 0, 5 pi on 4. And we note that their answer is different to ours because what they've done, and the calculator will always do this, is rationalize the denominator. Negative 1 on times that is negative root 2, and root 2 times root 2 is just 2. All right, so there's our answer to that one. And we're going to do the same approach, or use the exact same approach for all of these questions. So here's 210. So where am I on the unit circle? Here's 180, and we're going to go 30 more than 180. So we're here on the unit circle. Okay, what trig ratio am I? I'm sine, which is the y value. So what I do is I scoot across to the y value here, and I work out whether I'm negative or positive. Note that I'm negative. So this is negative sine. Now what I do is I don't know how to get the sine of 210. The triangles don't do that. So what I do is I go to the first quadrant, and I do an angle I do know, which is 30 degrees in the first quadrant. Looking across, that will give me the positive y value, which I then stick a negative sign in front of, which flicks me to the negative y value. So this is the same as getting the negative sine of 30. Now we know how to do 30-degree angles. It's on this one here. So here's 30, and we're doing sine 1 on 2. So sine of 30 is a half. So the answer to this will be negative a half. Right, tan of 330. Okay, so unit circle is drawn. 330 is 30 less than 360. There it is there. All right, so what I need to do now is work out what tan is in the fourth quadrant. Okay, so whether I'm going to be negative or positive. Okay, so tan, we can't look at either x or y, although we've got to consider both of them. Now, the way to do this is to think about tan as sine on cos. Okay, the sine is the y value, which is negative, over cosine, which is positive. So tan is going to be negative there. Okay. Now, what I don't know how to do is get the tan of 330, but I do know how to get the tan of 30, which will be the value in this quadrant here, and then stick a negative sign out the front of it. So that's just the tan of 30. Show you another version of tan next year, but this is the way we'll think about it. I want you to think about tan as sine on cos. Right, so the tan of 30, where is 30 degrees on my special triangles? It's here. Tan is opposite over adjacent, so it's 1 on root 3. And negative in this case. All right, the cosine of negative pi on 6. All right, so here's 0, and we're going to go back pi on 6. So the important thing to know is pi on 6 is 30 degrees, okay? And again, might be useful for you guys to convert that to degrees, or think about it in terms of degrees. But pi is 180, and 180 split into 6 parts means that it is a 30-degree angle. So this is where we are on the unit circle, is over here. That's pi on 6. Now remember, the next thing we look at, once we've got that, is we work out, we've got cosine. Cosine is x values, so we look up at the x-axis and note that it's going to be positive. So this is the cosine of, all right, and what we're going to do is get an equivalent first quadrant angle, which is pi on 6 in the first quadrant, which will also give us the same positive value there. So we're going to get the cosine of pi on 6. So go to your special triangles, pi on 6 is there. So that's going to be cosine is root 3 on 2. Okay, let's do a few more, so a fair few more. Okay, sine of 23 pi. Okay, so remember this one from last time. This is what we call odd pi. Okay, so odd pi means we're going to end up there. All right, now 23 pi is going to be sine. Sine is the y value at that point. That one's going to be 0. 5 pi on 6. So 6 pi on 6 would be pi. So this is pi on 6 less than 6 pi on 6. So we're going to be over here because on 6 means we've got a 30-degree angle. Okay, so that's where we are on the unit circle. Now, what are we doing? We're doing tan here. Okay, so tan is going to be sine on cos. Sine is positive, cosine is negative. So this one's going to be negative, tan of. Now, again, our special triangles don't have 5 pi on 6. So what we do is we basically get an equivalent first quadrant, which is pi on 6, and work it out from there. Now, I know that one, so I'm not going to keep scrolling up to look at the special triangles. You can do that with your notes, but this is going to be the tan of pi on 6, and I know that that one is -1 on root 3, or the calculator will say something slightly different. Shift tan of shift pi times 5 on 6. Okay, so the calculator will say -√3 on 3, so note that it will rationalize it. All right, 10 pi on 6. So let's simplify that fraction, cosine of 5 pi on 3. Let's find out where we are. So here's 3 pi on 3. All right, here's 6 pi on 3. So an on 3 angle means we're going in increments of 60 degrees because it's pi or 180 degrees split into 3 parts. All right, and we've got 5 lots of that 60 degrees. So we're going to be over here somewhere. Okay, so here is 5 pi on 3. We're doing cosine. Cosine is the x value. We're going to note that it is positive. Okay, so that's the cosine of, or the positive cosine of. Now again, our triangles don't support us in doing 5 pi on 3. So what we do is we get an equivalent first quadrant angle, which is going to be pi on 3. Okay, so that's the equivalent first quadrant angle. So it's the cosine of pi on 3. And again, I know that the cosine of pi on 3 is a half. You guys need to look up at your triangles and note that that's going to be the case. I've just used those triangles so many times that I remember them off by heart. You guys won't be at that stage yet, but that's fine. All right, so 7 pi on 4. Now, 8 pi on 4 is 2 pi. So 7 pi on 4 means pi on 4 back from 2 pi. So we're down here on the unit circle noticing that an on 4 angle means increments of 45 degrees. Okay, so this is where we are. Right, we're sine. So sine is the y value. The y value there is negative. So this is going to be the negative sine of, and what we're going to do is work it out in the first quadrant. So it's the negative sine of pi on 4, or 45 degrees. All right, again, I know what a sine of pi on 4 is because I've used those triangles often enough. It's going to be 1 on root 2, or negative root 2 on 2. So again, you can check your answers on the calculator, but judging by the number of memes found on a quick Google search of radians memes, be careful with calc modes. So if you're calculating an exact value for radians, make sure you're in rad mode. I'll show you what I mean. If we do it in degrees mode, it just won't work for us. It won't do the calculation. Okay, it'll give you an approximation, which is an awful approximation. Okay. So yeah, you need to be in the same or the correct mode. So radians is there, or 5 pi on 6, what's that? That is 6, that's 150. So I can convert that to degrees and ask the same question, and we get exactly the same answer in degrees. Okay. So the set work is from 4J. It's a lot of practice of those exact values. Heaps of tricks to learn that. I've seen people remembering things on knuckles and stuff like that. I don't know, Google it and you might find a few more. But the best way to understand it is be able to explain it and then do many problems. Overarching all of that, I think these two triangles here will allow you to remember or generate the exact values anytime you need to. So they're the ones that you do want to remember, those two specific triangles. All right, good luck with that, girls.